Alright, number 11 on 4.8 says a block of ice is placed on an inclined plane of 60 degrees. Determine its acceleration. The coefficient of friction is 0.2. Alright, so we know the coefficient of friction here is kinetic because we have motion. So 0.2. We also know our angle is 60 degrees. We want to know its acceleration if it's placed on an inclined plane. Alright, so let's draw our free body diagram. I never give myself enough room on these. Alright, so there's our block of ice. We have three forces acting on it. We have Fg, we have our Fn, and we have our kinetic friction. Okay, so our Fg is the one with components. We tilt our whole coordinate system so x is up and down the ramp. Our y is perpendicular to the ramp. That allows this force and any other forces acting in those directions to not have components. Okay, so that allows us just one with components. Alright, so we know we're sliding down this ramp here. Alright, we know we have an acceleration down the ramp, so that's in the x direction because our x is up and down the ramp like that. Okay, so set up our net force equation in the x. We have our Fgx acting down the ramp. We have our F sub k acting up. And we know that's equal to an acceleration. Okay, this is our net force that's causing the acceleration. So we set this equal to ma. And then our net force in the y is Fn minus Fgy, and that equals 0 because we're sitting on that surface. Okay, so let's look here because we want to solve for that A. Okay, so if we look at what's given in the problem, we're not given an m, so we need to do something that solves that problem, right? We need hopefully to get rid of that. So let's plug in our definitions that we have and see what we can do. All right, so Fgx, I should have put the angle in, angle. All right, Fgx would be Fg sine of that angle minus our coefficient of kinetic friction times our Fn, and that is equal to ma. We need to know what Fn is. We don't know Fg because we still don't know the mass. So our Fn here from the net force in the y is Fg cosine of that angle. And just to take it a step further, mg cosine of that angle as well. Alright, we have some more definitions now. Fg is mg Fn and that equals ma. So if we look now, every term has mass in it. So if we divide out mass, all of them cancel. Okay, so it does not matter the mass of the object when you're sliding down an inclined plane like this. All right, mu sub k g cosine theta equals a. All right, so we look, constant, we know theta, given, constant, we know theta. So everything on this side of the equation we have a value for, and that is our acceleration. So now we just plug and chug. And we get an acceleration of 7.51 meters per second squared.